Hello everyone, my name is KNN Valotto, and in this presentation I'll be explaining how the k-nearest neighbor algorithm works, commonly known as KNN. We will use a small dataset based on a student performance to illustrate it. Then, I'll show step by step how KNN would classify a new student, someone who studied for 7 hours and attend classes, to determine whether they are like to pass the exam. KNN is a simple and intuitive algorithm, and by the end of this video, you will understand how it makes predictions based on a proximity to an existing data. So let's take a look at our data set. It includes 5 students. For each student, we know 3 different things: how many hours they studied, whether they attended class. 1 means yes, 0 means no. Let's start draw. We have 3 columns. We will have 5 lines based first on study hours, the attendance, and if they pass or no in exam. Let's start to take our notes. The first student studied 2 hours, the second one 4 hours, the third 6, fourth 8, and the fifth student 10 hours. The attendance of the first one was 1, of the second one is 1, the third is 0, the fourth 1, and the fifth is 0. The first 2 students didn't pass the exam, and the last 3 students all passed the exam. We will use this data to train our KNN model and then classify a new student with 7 hours of study, and the attendance will be 1. Let's take our note. Study hours is 7, and the attendance is 1. So, what is the KNN? KNN is a non-parametric, instant-based learning algorithm used for both classification and regression. In classification tasks, like ours, the algorithm assigns a class to a new data point based on the majority class, its k-nearest neighbors. It does not learn a model during training instead. It memorizes the dataset and makes decisions at the prediction time. To decide who the nearest neighbors are, KNN uses a distance metric, most commonly Euclidean distance, to measure similarity between the new point and the training data. One key feature of KNN is that it's lazy. No training step is needed. It performs computation when making predictions, which makes it simple but potentially slow on large data sets. Let's apply our KNN to our new student. Just to remind us, our new student has 7 hours of study hours and the attendance of 1. We will treat each student as a point in 2D space where
x-axis is like study hours, and y-axis is like attendance. Let's write that. So, our new point is 7, 1. Now, we will calculate the Euclidean distance from 7, 1 to each student in dataset using the formula. Distance is equal x1, x2 plus y1 plus y2. Let's compute. Student A value total is 25, so it's 5.0. Student B 9 is 3.0. Number 3 is 2, and the numbers is 1.41. Number 4, the number is 1, and the square root is number 1 as well. And the fifth student, the student letter E, we have number 10, and it's 3.16. Let's write everything. Then equal 3.16. Now that we have the distance, we will choose k equal 3, a common starting value. So the three nearest neighbors are number 1, D, the fourth student, 8 hours and passed. The second one is C, 6 hours and 0 passed. And the number 2, letter B, 4, 1, and didn't pass. Out of the three neighbors, 2 passed and 1 did not. Using majority vote, KNN predicts that the new student will pass the exam. That's our prediction. So let's visualize the classification. I plot all 5 students on a 2D plane, study hours versus attendance. I mark it to the new student at point 7, 1. Then I drew lines connecting them to the 3 nearest neighbors. The visual makes it clear that most of the nearby students passed. So it's intuitive that KNN makes the same prediction. Let's check that. And now we start the comparisons. We have all the 5 students in the chart. And we want to know where's the number 7. What is the number 7 prediction? So we can check that it's closer for the students who pass. It's 2 versus 1. So the prediction is that the new student will pass. You should answer, what if is k is equal 5? If we had chosen k equal 5, we would include all students. Let's check their passed exams values. Then our conclusion to wrap up. KNN is a simple but powerful algorithm that relies cleanness to make predictions. We will apply it to classify a new student based on their habits and study habits and attendance. So we can conclude that the result is the same. Thanks so much for watching.